So just as a fun little exercise, I have adapted our marketplace code such that the items listed on the marketplace won't be stored just inside the local browser storage, but instead they will be stored on-chain and a smart contract will be used to keep track of them. So let's take a look. And by the layout and stuff like that, it will look pretty much exactly like the previous version. So let's just try to list one for sale. So now listing will prompt our wallet because it needs to update the deployed smart contract. And should take a second. And there you go. It's now listed, and what it did under the hood, so if you open the console, it should give us a transaction ID, and this is the actual update of the deployed smart contract. So let's maybe open it up in a block explorer just to see. I'll use Boston chain again, and I think that's the right transaction ID. Yeah, so this first output is pretty much the latest instance now of the smart contract. And the smart contract will get updated upon each listing and cancellation of a listing and stuff like that, and everything. The references to the ordinals will be stored inside this smart contract. So everyone will have one single source of this information, and no central server will be needed. Now obviously this is just a toy example, because in actuality you probably wouldn't want to store like thousands of items in a single smart contract on chain, since it wouldn't be efficient regarding the script size, but it serves as a nice demonstration of what is actually possible. So to keep this bonus video short, I won't actually be coding anything in this video. Instead, I'll just show you the code. So if you go to the from the previous video to the ordinal marketplace repository of the code, and you go to the on-chain branch, everything will be included in here. So if we go to the source contracts directory, it will have an ordinal smart contract, and this implements the actual logic of the on-chain smart contract. So you have methods such as list item to list new ordinals in the marketplace. Then you have buy request and cancel buy request and cancel listing. So yeah, maybe an interesting caveat of this smart contract is that in order to avoid direct communication between a buyer and a seller, the contract itself implements this mechanism of having a buy request and confirming that buy request. So because the smart contract itself only stores references to ordinals, so this is just transaction ID plus the output index, which we call outpoint in this. Then that means that upon a confirmation of a buy request, the contract ensures that this transaction ID, or this UTXO rather, is actually unlocked and the ordinal is transferred to the buyer. So that's pretty much it as for the contract. That's the biggest change here. As for other code, it's pretty similar to the previous version, but now obviously you have a contract subscription just to get notifications when the smart contract gets actually updated, such as when a lab listing gets added. But other than that, it's not too different. So yeah, you can clone this, and I'll leave it up to you to figure out the rest. I hope you like it, and stay tuned for tutorial 4. Until then, have fun coding and goodbye.